Cool. Hello everybody. It's time to solve some Codeforces problems. Not very hard ones, not trivial either, around difficulty 2000. As almost every Saturday. Hi, Moralizer. Are you some enemy of Demoralizer? Yep. My best bet should be, I think, to go to problem set and solve recent problems with difficulty around 2000. I just need to hide tags for unsolved problems, so it doesn't matter. All right. Maybe we'll start with these two as a warm-up. Correct placement and New Year's puzzle. I can skip something if it's too hard. Need to ping on Discord. No ping on Discord? I always do that after like a minute or two. Stream pings. Right, correct placement seems to be a very long problem. New Year's puzzle. Seems colorful. Is it a cool problem? Chat, tell me. Oh no, title isn't updated. Versus problem solving. Right. I keep forgetting. And then in past recordings, it's displayed with a wrong name. Christmas t-shirt? Yep, that cool t-shirt. What topics? All of topics. Right. You need to solve the New Year's puzzle. Polycarp got the following problem. Given a grid stripe 2 by n, some cells are blocked. Tile all 3 cells using the minus 1 by 2. If those 2 are blocked, then yeah, I can do this, that. Can you solve it? Oh, you just need to print yes and no? Yep, it's a fine problem to figure out. Need to clean up my desk. Also, I have so many tabs open on the other screen. Not able to degrade the video quality. You can watch on YouTube if you want to rewind and decrease the quality. We have a very long stripe with length n. Oh, I'm not connected. Yeah, merge, sure. All right, link command should work. Hi, Enriquez. I'm fine. I spent some time on Chinese remainder theorem today. If we have a very long stripe, but we don't need to color, we just need to say if it's possible or not. Let's think when it's impossible to do it. It's for sure impossible to do stuff if the number of available cells isn't divisible by 2. In particular, if this is a blocked cell and this is a blocked cell, then I cannot cover those 5 cells with blocks of size 1 by 2, like this or like that. My first idea is checked connected components. Also, is chat displayed properly? Should it be bigger, smaller? Everything's all right? Are you playing some tutorial? Yeah, I do. Chinese remainder theorem and prefix sums are in progress, in works. Cool. So what about this? For every connected component, like if there are some disjoint parts here, this is a very long stripe. I think we just need to, like, if this is the case, then it isn't only about connected components with even size, right? What if this is the case? Blocked, 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 blocked. For this, the answer should be no. You cannot cover this with 2x1 domino cells, domino tiles. Can you use DFS? We can't. Length of this stripe is up to 10 to 9th power. You cannot even keep that in memory. The answer here is also no. That's because there are 5 cells here. So for sure, if there is any connected component, this one, of odd size, then this is bad. But also, this situation is bad. Even if, in a bit simpler test, if this was blocked. Here we have 4 cells, so it's even, but I cannot do anything. Do I use signal up? No. Why do you ask? What is signal? Can I recommend a good problem? Not yet. I will solve this one first. What about this? Length is huge and I cannot process it, but big parts will be empty. This is the problem statement. So length of the whole stripe is up to billion, but the number of blocked cells is much smaller. Then I think I will just shrink this stripe a little bit so I would be able to run DFS or something like that, maybe DP. Elon Musk recommended signal up. Okay. I mean, I will not consider switching to some app before a lot of people go there. All right. If we have a blocked cell here and then nothing is blocked there, the next blocked one is here, maybe something more is on the right, then I think it's good to shrink this part. I don't know if completely, but I would say that we can just assume that the drawing is like that. Maybe I will shrink by squares 2 by 2, because then I'm quite sure that the answer will not change. So at least shrink as long as this part is very long, then get rid of 2 columns repeatedly. So this drawing, I shrink down to this drawing. Would that be good? The implementation will be something like that. If I have blocked cells sorted by columns from left to right, this is column 2, this is column 4, 5, 7, then I have that sorted to 7, and if I see a big gap, I want to shrink this gap by by a multiple of 2. In this case, 7 would get down to 5. And then everything in the future, I also remember I shrink you by 2. And then once the length of stripe is small enough, then we can do like whatever, DP, DFS, something. I would say DP. I don't think it's worth implementing. Let's see in the tutorial if this is it. Everyone is switching from WhatsApp to Signal now. I can bet that not more than 1% of, I don't know, WhatsApp will switch to Signal. Shrinking looks hard. First, I want to see if that's the solution. Okay, they have something else. Okay, they have a different solution. Then maybe I want to implement this. I think that also you are not sure how to do it. More than 1%, I think, because of new privacy policy of WhatsApp. Sure, but I believe that many people will switch, but it's not that 50% will do it. Of course not. People are used to something. They don't switch that easily. Can you prove the shrinking part? No, but it seems intuitive. Oh, let's try. Let's try to say a few sentences about this correctness. I want to say that the answer for those two stripes is the same. Why? If I have this even part, then if it has a solution, there are two possibilities. Either here a domino piece on the left is like that. It's impossible in this case, but in general, it's something like this. If it's like this, then the other guy must be like that. So here everything can be connected with each other. Then the same principle goes here. Alternative feeling is if this is how we should put a domino piece here, then because of parity, here out of 8 cells, 6 of them can be paired up. So this will be the case. Now, can we do this part? We can't. What about here below? We can't either. If this had odd length, then we could. Something like this is possible, so then this would have odd length. But still, I showed that the answer is no in both cases. Seems to work. But also maybe I'm starting to move towards the correct solution because of what I'm analyzing here. We are discussing the F from recent division 3. I don't know. New Year's puzzle. You can always grab a link by typing link command. So, shall we implement this? Do we have Gene here? What do we want? FCPP. Oh, now chat will be not displayed properly. What should I do about it? I can add a dark rectangle. Wait a minute. Okay, nope. Something like that, just make it partially transparent. Next time this will be more professional. I'm trying to remember where to change transparency. Command say something? What, me? Put it in the middle of a screen. Just cover everything. OBS Studio. Spot. filters, add color correction, set opacity. Right? Should be good, kind of. Sorry about that. Do you know Pasha Biceps? I heard that name. It's some big YouTuber or streamer, right? Right, time to implement something. There are test cases. And the goal is to solve a test case in complexity of the number of blocked cells. There is length of everything and m, the number of blocked cells. Then blocked. Row and column. Because I want to sort by columns, I will put pairs in order column and row. Then when I sort, they will be sorted by column first. Right. I will also add a fake cell, a blocked cell at column 0. And row, I don't think row is important. And place back. Then plus 1 minus 1. Right? What I did is I told my program that there is some fake blocked cell here and there, on the left and on the right from the full rectangle. This way, I will shrink those parts from the left side of the stripe, like rectangle, to the first real blocked cell. I don't want to have huge part of length 500 million first, that I would go through that. All right, now the compression part. And place back with brackets. Why are you correcting me to something unnecessary? If you want to correct my code, then first think for a minute. Are you sure about it? Because with pushback, you do need this kind of brackets here. With and place back, you don't. Okay, now the compression. How does and place back function work? It puts this pair at the end. It pushbacks this pair, but it is a bit faster. For every pair. For every pair in blocked, they are sorted by columns. Now, when I look at this column, I also want to know what was the previous column. And if the distance is big, so it will be something like that. If distance is bigger than previous column plus 2 or something like that, then we shrink a little bit. This will be offset. This will tell us by how much we already shrinked everything on the left. So now if new column 10 will come, but I knew I already shrinked by 4, then 10 actually will denote 6. So this I will put here col minus shifted, comma row. Row is not that important. Shifted plus equal. Let's see. This is the difference. The distance. Actually, part between them is this minus 1. If diff is at least 4, be 3. 3 should be enough. 4. The bigger value I choose here, the more certain I will be that this is correct, but on the other hand, samples will become useless. 1 year of hard work to get to IOI? No, it's not enough. Diff divided by 2 times 2. This would give us, like, if diff is 7, then this would round it down to 6. And now I actually don't want to subtract that much. Maybe minus 2. What about this? This means that if I see a difference of 7, I will round it down to multiple of 2, so to 6, and then we'll subtract 2, then to 4. If I see something of length 7, I will shrink it by 4. All right. Now everything is compressed, and I just want to do standard dp or something. What should that be? And now I know that the length is small enough. For starters, let's print what compressed contains for these tests. Still, the first and last elements, they are fake, but here we have 2, 2, and 1, 4. This is basically nothing was compressed. In the last one, something is compressed. Like 2, 6 was changed to 2, 4. Let's remember that I swapped row and column. Did you do some sort of coordinate compression? Yes, you can say it is coordinate compression, just a bit smart. It's not that when I see something and then something far away, I just say that it's this plus 1. I want to maintain parity, same parity of differences, and I wasn't sure if I can really shrink it that much. But you can almost say that a sequence like 2, 5, 6, 10, I would shrink to just 1, 2, 3, 4, but saving the parity. So let's say that 2 is supposed to still be 2, 5 would be 3, 6 would be then 4, and 10 would be 6. Something like that, but I wanted to leave bigger gaps. It's almost this. All right. We have this blocked. I want to create an array like this one, 2 by length, but this is a new length. What is the new length? It is compressed back. First is a column, minus 1, because this is element 1 after everything. Have something like that. Now for every pair, if this is not minus 1, if this is a real element, then is blocked. Okay, like that. I subtract 1 because now I have numbering from 0 to n. I mean, from 0 to n minus 1. This is pseudocode. Actually, this should be vector of vector values. It's nice to use vectors in C++. It's better. Even though you need a bit more typing. Print if everything's okay. What's wrong? N is not available because I want L. I want len. What else? Redeclaration. Yeah, let's overwrite. Oh, you don't see compilation errors properly. And this maybe needs to be in brackets. There is SRM in few minutes. All right. So go to top coder if you want to participate. Some kind of mistake. GDB F. Run on input in. BT stands for backtrack. No, I don't even remember. Anyway, we have a mistake in line 66. One of those two values. It's outside of the thing. Well. Len is free and we have those. Why is this the same thing? The fake element after the whole rectangle should have bigger column value, not the same. So something is wrong here. Len plus 1. Maybe something's wrong with this compression. Oh, previous column. I don't save it. Okay, now should be better. Fine. First, after compression, first sample test is this, then second, then third, which I believe is just the default state. And now we can assume that length is small. And yep, we can do. How will we do it, DP? Should be easy. I would say that there are three possible states. Either that we move. When I'm done with some part, then new domino piece will be here or here. If in both positions, I will just say that this is vertically in both positions. So this, or that, or both are empty. Make sense? I'm for sure overcomplicating this. DP or greedy now for sure. Let's see. State can be nothing, or up, or like top, or bottom, or both. No, both is impossible. There are three possible states. Initially, it's nothing, because it's not that some horizontal domino passes to the right. No. If is blocked of 0 in this column, and state is equal to top, so we tried to move with the top row. then we would say that, nope, this doesn't work. Similarly, if the second row is blocked and we try to move that way, right? What's now? Now everything should be fine. Let's say this. Like we got here. If state is top, it would mean that somebody put domino piece here, and now we are looking at this column. That would mean that basically, let's say, oh yeah, I have a density. It just denotes that these two cells are blocked. Blocked. If I put a domino somewhere. Yep. Then we will not even need that. I will not even need a state. Look at that. If neither of them is blocked, then both become blocked because I just put a domino piece there. But now, after that, if one of them is blocked, if one of them is not blocked, I will visualize this in a moment. Then we try to do this. We say that domino piece is put here and also on the next column. I say we try to do it because we don't necessarily succeed. I can just make a not blocked. We try to do this. What does it mean? If it's already blocked, or column is len -1, so this is the last column, then this is impossible. Yes, no, no, that's correct. Let's not print this and submit. I will show you on a drawing what happens. For every next column, something happened here already. I put pieces there. Then in this new column, if I see that both cells are empty, I put a domino like that. You might say, hey, maybe we need to put two horizontal dominoes, but then as well, I can put two vertical ones. So whatever. Okay, if one of them is blocked like this, then there is only one thing I can do. Put a domino piece like this. So for that, I check this next cell. If this cell is already blocked, then I print no, this is impossible. But if this is empty, then I say, okay, domino piece is put there. So the next column would know what's happening. I just mark this as blocked because I put something here, so I shouldn't anymore. And that's it. That's the logic. Accepted. Try random test for your code. But what's a random test? If I really put a random test, the answer will be no. If you mean a small handmade test, then well, samples are for that. I thought that my solution is correct. I was quite certain about it, so I submitted. The mask thing was beyond my understanding. What mask? I didn't use any mask. Oh, okay, lost coder. Okay, sorry. Could you see question E of the same contest? It had a long statement, so no. Cool. What's next? I can do E if you think that it's a cool problem, but I opened it for a moment and it had a long statement. Something here maybe? I will appreciate suggestions for easy problems. Not easy, sorry, never mind. for recent problems. Something that we see here on the screen. G maybe also is fine because it isn't that much more difficult. One 442 is too old. 1467. 1467D. Sum of paths. Maybe. It has proper difficulty. Division 3 not cool. There's the sum of paths. I don't know, statement seems complicated. Correct placement. Long statement. What was there before? This was a standard round. Similar sets. Why did I open it? It's some kind of ICPC contest. Recent problems Neil already explained. Same for old problems. All right, so fine. I will do something older. This is educational promise. This water balance. But it's division 1C, it's too hard. What is the difficulty of that? Who suggested it? Vatsal. What's the difficulty of this problem? You don't need to repeat your comments, come on. And with different explanation. This is old but nice, and previously this is educational, I promise. Why don't you use bits stdc? What? I don't use it? Then what is this? It's 2100. All right. We can try that. I will read it. And water tanks in a row with some amount of water. No, I know what I will do. In standings, how quickly people solved it. What is your code above? No, don't look at it. It's bad. It's ugly. So what I want to do is go to this contest, standings, and how quickly people solved C. People in the top solved it in 5 minutes. Up to 10. No. I think it's too hard. But still, I will read it, just because I'm curious. Choose subsegment, redistribute water evenly. In other words, replace this with averages. You can perform any number of times. What is lexicographically smallest sequence of volumes of water? All right. This is a link. Seems interesting. No, I don't want to merge. If sequence is 7557 and I want to create lexicographically minimal sequence out of this, I should apparently change 755 to its average. Is the lag huge between stream and chat only for me? It should be around 5 to 10 seconds, I believe. Remove the comment from your screen? What do you mean? The chat? Does it cover something important? Right. Hmm. Now this rectangle is unnecessary. Yeah, it's bad. Chat is annoying. Why? I don't see how it's bad. Anyway, I want to decrease this number as much as possible. Should I always say that I will choose some prefix, and out of all prefixes, I will choose the one with smallest average? Maybe I should make first some sequence of moves, and then thanks to that, the situation will be better. Can it happen that we have a sequence and I first merge those together, only to then do an operation like this? Well, this makes sense in this order only if this was a small value and it allowed us to decrease those. But then I would say that it's better to also grab it as a small value. So I think that the first operation should always be something on prefix of the sequence. Lag is more than 4 minutes for me. Oh, really? Yeah, maybe refresh. All right, so let's assume that the lemma is correct. What then? I can have multiple choices for my prefix. Which one should I then choose? Let's create such an example. 7 and 5 will give you an average of 6. Then maybe there's something big, but after that something small. 4. This will average to 6 as well. And then something. And then I need to first choose between merging this prefix and this one. I think that it's safer to merge this, because I can always later merge this into 6s. I think that I should do this. If I want all 6s, then when being here, I will merge that into 6s. Because I can do some operation in the future, it's not that I need to do it now. So my claim is that, call it a lemma. First choose prefix with smallest average and ties this side by length. Right? I need to leave this rectangle. Does it work on samples? It would work here. 788. Here I don't do anything. And there, 5s. This change into 5s. Then that into 5s much later. Seems alright. But n is big. We already see how to solve a problem in quadratic time, comparing prefixes. Can I do it better? Also, after doing this prefix, can I jump to everything after the prefix? Maybe. Let's think what happens after I get rid of the prefix. No, nothing interesting happens. I'm thinking about some kind of deque. I'm not sure. Maybe ties aren't important. Maybe we can arbitrarily decide ties and it will still be good. Maybe then it's easier to implement. If I decide to first choose this short prefix, if it's long prefix and I can then skip it and move to the rest of the sequence, it's all fine. If this is a short prefix with small average, starting from here, I need to find the next best prefix. If I tried to find prefixes from here and compare them, would I have the same priority of prefixes here? I don't think so. So we divide something else. Or maybe? No, it's different. I think. If those were here small numbers, like let's say 444, and then maybe let's see. If I say here 6 and 4, and then 654, then it's all the same. Like if the average of this is 5, and the average of this is also 5, then when I was looking at that from the very start, the average up to this moment was smaller than up to this moment, because 4s were better. So the priority of prefixes, the order of prefixes changes. I'm not going to remove the chat today. It will stay for sure. I can reconsider it after the stream. What do we do? Let's try to write down something. We care about, if we are already done with some part of length x, then now we compare prefix of prefix sum up to I minus this removed already part, this divided by I minus x. So what? And by x I mean this position. That, oh, already here I found this best prefix, and now I need to find the best one starting from x. We need to find the best I, minimizing this. Yeah, I don't know. Maybe let's try to understand how the final good sequence looks like. We have this sequence. And I believe that we'll merge some interval here, then maybe this one, this one, this one. I think that those intervals will not overlap. And every next one has bigger average, otherwise we would take it for shorter prefix. And initially, if points look like this, then each interval gets down to the average. Like this. Maybe after I optimally split prefix, I can look at the next number, so like a stack thing, maybe a bit similar to convex hull. Let's say that I'm done with those 5 elements. I saw that optimally I split this into, I merged that. So I have 4 elements, each of value 7.5, or the sum of 30. Then here I have initially, say, 8, maybe 10. Then I keep that in a stack. There are 4 elements of value 7.5, then 1 element of value 10. And now comes something with value 9. What will happen? It will keep merging with last value in a stack, assuming that it's greater than me. And that's it, that's the solution. What can go wrong about it? I think nothing. If we want to use 9 for this, and everything is already increasing, then sure, first merge with that. Split on non-decreasing segments, I don't agree with that. So if we have this, non-increasing to decreasing 4, 5. In this case, it's better to merge all of them, because 5 is smaller than 6. So it's not that here I should put a bar like that, because 8, 4 is decreasing, so it's better to merge them into 6, 6. But after this merge, they should be merged with 5. So here everything is merged. It isn't true that I should look at input sequence and put bars between increasing parts or decreasing parts. How does calculating prefix average help? Because I simulate this process. I say that I optimally split the prefix, like I optimally merge the prefix, then I see a new value. If a new value is to help, let's say, the first value, it would need to first help everything in between. More or less. Yeah, I will check in the editorial if that's their solution. If no, then I will implement mine. Only the sum of the segment matters. So they literally treat that as a convex hull. I'm not then sure if it's equivalent to my solution, but maybe. Right, let's implement my solution. Then we'll get a counter test or not. I also think that it's equivalent, but because of this difference, I will implement. We have pairs of value and count. This is, you can assume that it's a stack. I will first put some fake value that doesn't try to merge with anything. Let's say -1 with count 1. 0. But then n times read a new value and keep merging with the last pair in a stack. Well, as back first, well, you can improve it. Like this average is 8 and you are 6. So this thing is greater than this new value. Actually, it will not be value anymore. It will be something else. Then we would say merge. Average is value, count is 1. All right. Merge of those two things. New average is, well, instead of average, I think we should just look at the sum. It will be easier to merge it. This divided, so their average is better than my average. I mean worse. Then new sum, increase the sum and increase the count. And now we need to what? Print the sum, print the sequence. I start from 1 because I want to skip the 0 fake element. Sum divided by count. Each value is equal to that. That's not it for sure. Is this some kind of infinity? Oh, I didn't copy proper input. Yeah, looks good. I'm a bit too lazy to submit for other samples. Let's try to understand how is this related to a convex hull. There are a lot of nice problems that are about sequences and then they turn out to be equivalent to convex hull. Comparing those ratios, this has something to do with convex hull as well, I guess. I have quite a big time. Can I improve it? How would I? I can avoid division here. Yeah, I wonder if this will improve stuff. Count and this is always positive, so I can transform this a little bit. I'm just curious how the time will improve. Maybe it will not. And also, if I remembered sum divided by count, so I would avoid dividing multiple times. Would that help? Maybe printing and reading is anyway like most of the time spent in the problem. I avoided division, at least in some cases. Yeah, nothing changed. So I think that reading and printing is slow. There are faster methods than scanf. Well, n times n? What are you talking about? This was linear. Exchange arguments video or consume average of interval to be this. How to read faster than scanf? There are some methods. There is like put, something with put. I don't remember exactly. You will be able to Google that in Codeforces. How to create a macro for scanf and printf? I have no idea what macro are you talking about. I don't have one. Yeah. So this drawing was for values from the input. But what does it mean? So I got accepted. Let's try to understand why. The first value is big. Then let's say there's something smaller. Like that. This is index and prefix sum. Then I don't want to merge with the next thing because it's actually bigger than me. If this is below, then I... Right. I want to merge those two things together. This corresponds to, let's say, if this is 5 and this is 7, it would mean that the first value in the input was 5 and the second one was 2. We deal with prefix sums here. So this would mean that I want to merge this because I want the first element to be what? 3.5. Then if the next number is smaller than 3.5, so if we have something smaller than 10.5, what sense does it make? Got accepted, now understand why. Epic level. Yeah. Sometimes, especially in practice mode, you should spend some time understanding what you did or what editorial does. Actually, yeah, this is an important lesson. You don't stop solving a problem the moment you get accepted. You stop the moment when you understand your solution and solution from the editorial. Add timestamps if you're uploading to YouTube. You can create timestamps and put in comments, then I will add them to the video. It's a lot of work. This is above 10.5. What does it mean? Why? How? Oh, this is just... the first prefix sum is here. So far convex hull will be like that. Now, if this next point is below 10.5, like that, because the next number is small, let's say the next number is 2 as well, then instead of red line, it's better to take this one. That would mean that the first 3 points are combined, are merged. And let's say then there's something big. Then I don't want to combine. This is a bad drawing. I need to put points a bit lower. Let's say that we have this. This would represent the first number being high and then every next number being quite low. After that, This is some point. Now we have, this is quite big, but then there's something smaller, a bit bigger, but then again smaller. Then this should be merged and it will get a value of around here. What is the meaning of this? The meaning is that, first of all, I want to minimize the first value. If I know what is the prefix merged together with the first value, let's say that somebody tells me that everything up to this point, everything here I will merge. But this is prefix of I, the height of that. So prefix of I divided by I is this slope. And prefix of I divided by I is the first value. I want to minimize it. So I want to minimize the slope. What does it mean? It means that I want to choose such a point that slope of such a line will be as slow as possible, and that's this point. Bottom convex hull finds, looking from 0, 0, the first such point. If we have this ray and then we slowly rotate it like that. All right. Then starting from here, it's the same situation for the rest of the sequence. I treat this point as 0, 0, and I want to find this point with lowest ratio of your prefix, minus this one, divided by the difference in indices. This ray has the best slope. Cool, I understand. And then I see why it made sense to do something with a stack, because convex hull is done with a stack. So apparently I did equivalent thing. All right, next problem. I accept suggestions now. Your exchange argument block has similar trick problem. It was a long time ago. Which problem? I'm trying to find something similar here. Codegem 1 where 0, 1 average. You're given binary string. Oh, this one, yes. In this one, indeed, we needed to draw prefixes. I agree. Yes, it is similar. But all of that was harder than I would like to cover in the stream, so let's move to something easier. I would prefer to solve Codeforces problems. I'm looking at the chat, taking suggestions. Something below 2000 maybe now. Full turn. This is not from a Codeforces route. No. Solving problems randomly or topic-wise. You need to do both. When you learn a new topic, solve 2 or 3 problems about it. Then get back to solving problems randomly. Solving problems about a single topic has a big downside. You know that you should use this topic, so you shouldn't do it forever. Right, if something was from ICPC NERC, why are you saying it's division free? Oh, wait, it's not no such problem? I couldn't open it? What's going on? So this link doesn't work? Yeah, no such problem. What? Oh, because of minus. Just cannot copy the whole thing. So I started with this problem today. 3 bugs. Right? Let's see. This is the link, but I'm still deciding. You're given 3 bugs. Non-empty multiset of numbers. Choose 2 non-empty bugs and choose 1 number from each of the bugs. Then remove B and replace A with A minus B. The first bug has this. We're solving this, maybe not with code. This is the link. The first bug has values 1 and 2. The second one, 6, 3, 4, 5. Then 5. This is listed here below samples. Applying an operation on 1, 6. It gets rid of what? Oh, we can have negative values. We can choose any two. We can get rid of 1 and then 6 will change to 5. Or we can get rid of 6 and then 1 will change to minus 5. Find the one which has the maximum number left in the end. Neil explained this yesterday only. I understand that recent problems are usually explained, but so what, should I now only solve old problems? Maybe. I'm not sure. Maybe I will not implement. This stream is a mix of you learning something, but also seeing how I approach a problem. At least that's a new part. If I don't see if I don't know a problem, then you get to see how I approach it, not just explain a solution. When we have only 3 numbers, 1 per bug, what can we do? We can remove A, and then we'll have, let's say, I put it here, B minus A and C, and this is empty. Then I can have B minus A minus C, or I can have C minus B plus A. This is what happens if I first remove A. And by symmetricity, I will have some other possibilities. If I remove B instead of A, then I can have this. If I remove C instead of A, then it's the same thing here. If here I swap A and B, I will have C minus A plus B. And yeah, that's it. Those are the 4 possibilities, I think. Something is suspicious. It shouldn't be 4. C twice is negative, twice positive. B is twice positive. Oh, maybe it is okay. No, it isn't. Why do we have B and A minus the other 2 and not C minus the other 2? Something's strange. Yeah, I expect some symmetricity here. Again, if I decide to remove A first, it can go to B. Oh, I see. But I only consider that A goes to B, and then I said I have some symmetricity between AC, AB, but also between B and C. Right. So if we can get one number minus the other two, and sum of two numbers minus the third one, then I think that we can have this plus C, B plus C, any two numbers minus the third one, but also A minus B minus C, B minus A minus C, and C minus. Now forget about that. Just from symmetricity. If you can get one, you must get also the other cases. If we want to maximize things, then I will take the biggest number with plus, the smallest number with minus, and about the middle number I can decide. What if here we have B1 and B2? Let's think about it this way. When a number gets to a different bag, it is multiplied by -1. Everything will end up in some bag. Let's say that at the end I will have here, this is the end. It means that if something travels like that, it will be taken with minus at the end. But I can also do this. Then it will be taken with plus. If it's positive, then obviously I want to do that. But I don't think that all the numbers can do this trick. It's not that I can do this, I can do this, and also the same thing for A. Let's say that A also wants that. A wants to be moved to the second bag and then moved to the third bag. Because each of them I want to take with plus at the end. Anyway, the crucial observation was that changing a bag multiplies number by -1. So just we can focus on how a number travels. When B2 is moved to A, still it will, along with A, travel in the future somewhere. Right. So it's not that I can move all the numbers exactly twice, because there must be some order of them, and some of them will be moved last. That one is only moved once. So I would say that if we have something like this, there is A1, A2, A3 in the first bag, B1, B2, B3 in the second bag, C1, C2, C3 in the third bag. I'm not sure yet about those, but for this, it is possible to move all of them just in one move to the third bag. Then all of them will be taken with a minus. But maybe they are all positive, and all of them want to travel in two moves, so they would be taken with plus. Then still I need to choose one. If A's want to first travel here, then there must be some special BI such that it will travel there in one move. In this case, B's will also travel like that in one move. So all B's are wasted with multiplied by -1. Maybe we should leave aside a single AI and single BI and do something like that. Both A's move here and then to C, and A3, both B's move here and then to the third bag. This way we can get majority of values with plus, taken with plus at the end. We need to leave aside single value AI and single values BI. Read constraints again. All right. I see. Everything is positive. So we prefer to, thank you. We prefer to make two moves to put number at the end in some bag. What happens with C's if we do this? Well, one of C's must stay here, otherwise there would be no way to be in this bag at the end. So I need to leave aside a single CI, I guess the smallest one. And for them, they can move to, let's say, this B, and then to the third bag. So one possibility is that everything from every bag, I leave the smallest number aside. Everything else is taken with a plus, and those are taken with a minus. What else can I do? Actually, wait, C3 also is taken with plus, no? Yes. Those C's, they travel 2 moves, but C3 travels 0 moves, so it is taken with a plus. So I don't choose in the third bag. Everything other than single AI and single BI will be taken with a plus. And those two with a minus. Suggestions for questions after you solve this question? Yeah, sure, after I'm done. Can we do something else? We can move everything from A's to B's. Consider these edges. Like that. Of course, some C's will travel like this, but I don't even want to draw it. B2s cannot do anything smart. If they do this, that will be odd number of edges traveled. Same here. This is not allowed. Right. This allows us to take all of that with plus, all of that with plus, and all of that with minus. So I found 2 ways. Stupid default color. Either either take single AI and single BJ and everything else with plus, or take everything in B with minus. Everything else will be with plus. I see those two possibilities. Obviously, from symmetricity, I can do the same thing with C or with A, but everything will be taken with plus other than the single bag, everything in the single bag, or single element from 2 bags. Is this enough? Let's check samples. Sum of everything would be 3, it is 10, 20, 26, but those I take with minus. So instead I lose 6 because I don't, instead of plus, I get them with minus. So it's sum of everything minus twice single bag. What about the other case? Maybe here we will take those two. 1 and 2 seem to be 2 small values. Sum of everything is 16 plus what? 25, 27, 34, 35, minus twice 3. Okay. The 2 samples cover 2 cases. And because of how short the code will be, I'm going to implement it. the size and 0 and 1 and 2 and sorry, and 3, and there are actual vectors. Input done. What now? Compute sum of everything. And subtract either one single bag or two smallest elements from two different bags. Let's compute a sum in this bag. Because I want to maximize the last number, I want to minimize the lost part. I minimize this thing. Like that. Also considering two elements. This will be unnecessary sort, but let's say why not? Sort is very fast. I do this only to get the minimum element. But now I say that I consider a of I 0 with a of I plus 1 0. I can lose two elements. This is taken modulo 3. This for loop will consider taking two smallest elements from two different bags. Twice lost because instead of with plus, you take with minus. If instead of plus 3 you have minus 3, that's difference of 6. Right? This time I will test on both samples. It's because of how different they are. Works on samples. Why declare int x inside the loop? To make your code nice. You don't want to, let's say, yeah, sure, you can create stuff here, but then you might reuse something by mistake. It's not that this really slows code down significantly, but it's much better in terms of coding practice and just to avoid mistakes. You don't, like, other than here, you don't want to access this x by mistake. It will not be more efficient. Compilers are very smart nowadays. They understand that I would guess that compiler will not really create a new variable here every time. It will understand that it can reuse the same one. Compilers are smart and they make your code fast. It's a very bad idea to leave this outside. I think declaring long is a bit faster. What? Like creating a new long variable? No way. Yeah, you can use longs if you don't want to care about overflows, but then you go to real job and you will have a bad time. All right, that was a nice, non-difficult problem, where mainly we needed to analyze the process, understand it. So it's not that you should jump to coding or to thinking about an algorithm. Very often, if problem isn't trivial, you need to, sit down with some kind of drawing and understand what's going on. Notice that first I did something unnecessary because I didn't know a solution. I analyzed what happens for three numbers. And yeah, I listed down possibilities. They didn't really tell me a lot other than the fact that I cannot have the sum of everything. But then I thought about the fact that every time a number is moved, it's taken with a minus. Because why this thing has, or why here we have b minus a minus c? Because b didn't travel, a traveled once, c traveled once. Right, next suggestions for next problem. Firecrackers. Why is it again from ICPC? I think we want to solve problems from Codeforces round, don't we? If you think that some ICPC problem was very nice, then sure, I can try, assuming that it isn't difficult. If somebody confirms that it's a nice problem, then okay. Every number has, indeed, it's -1 to the power of how many times it travels, because every time it's multiplied by -1. I had 10 messages at the beginning of this stream. Now I have 12. You can estimate with this how many messages I get a day. All right. All of that is from ICPC, right? Firecrackers. It says 1700. Maybe. What is possible here? Firecrackers, full turn. Something else? Road reform. Maybe this one. I have grad contest problem if there's nothing. I do those on Tuesdays. So on Tuesday I can solve it. Maybe I will try firecrackers. Somebody suggested this one, water level. Is it alt? I don't remember what is the current round number from 6 contests ago. Right. Let's read both. And we'll do voting. Unless I already decide that it's very nice. Road reform might be too easy, right? But, it's not that it needs to be interesting to me. It needs to be proper difficulty for you. Water level is better. I will read it first. We start with k liters of water. We want to have something in interval from L to R. Each of t days, exactly x liters will be used by colleagues. We can add y liters. Is this like Flappy Bird? You have some range, you drop by some amount, and you can raise by some amount. It very much looks like Flappy Bird. Y can be smaller or greater than y. Right. Hydrate. I wanted to make a command for hydrate. It will be here next time. Right. This seems to be a cool problem, so let's do this. Link. I'm going to draw the first sample, and because I think it's Flappy Bird, I will draw it this way. In the first example, we have interval from 1 to 10. We start with level 8. And what are the other values? T is number of days. We need to survive for 2 days. X is also X is small, Y is huge. Colleagues will eat 6 liters of water. So gravity is of power 6. And then we would be at -4 if we do nothing. But also we can go up by 4. All right. First, from 8, I cannot raise to 12 because I would hit the ceiling. I need to drop by 6. Then from 2, I can raise to 6 because I can use this move. I'm not allowed to use it twice. They said that we need to add exactly y liters of water. So from here, I will anyway drop to 0. And that's below 1. That's bad. Everything is up to 10 to 18. Only x, the drop, is small. We will likely need to find some kind of cycle. There is interval, and I can first decrease everything properly at the start to say that the start of this allowed interval is 0. This is some height, actually equal to the difference r minus l from the input. Maybe instead of this, I should just draw the ground and the ceiling. Right? Start somewhere, and normally I will keep dropping. And now I will drop too low, but I can use this move of refueling, of going up, and yeah, it moves me up by some amount. It's whenever possible I will use it. I think that's obvious. Just I cannot use it too high. There is some boundary such that above this I cannot use my move because I would hit the ceiling. And yeah, after I use it, this distance is exactly up, the amount by which I go up. From this position, I again keep dropping. And now, if this distance, if this thing is smaller than drop, no, if it's greater than drop, then almost always the answer is yes, that I can survive. That assuming that up is greater than or equal than drop. If those two are true, if they are together true, then it's yes. Because whenever I get here, I will move a bit higher. So even if I drop, I will not be lower. And assuming that I survive the first turn. What happens if this is not true? If up is smaller than drop, then maybe at the start a few times I will drop without being able to go up. Oh, that only once I can do this. Yes. So I now investigate the case of, let's say in green. Up smaller than drop. At most, maybe in the first day I cannot use up. Maybe I can. But starting from the second day, for sure I can. Because drop and then up by a little bit less than that. I keep going down. I just need to check if after exactly 2 days I'm still above 0. If yes, it's cool. Okay, so up smaller than drop. then check days first and t. And we know that we drop every time in between. Otherwise, I can assume that this is true. And if this part is bigger than drop, then we have yes. This I already can forget about that. So what if this part is smaller than drop? This part is quite small, and also up must now be greater than equal to drop. I can assume this. And also that this is smaller than drop. This is short. This is possibly big, but there is some small drop. But still this is smaller. Let's make a reasonable example. This distance is equal to up still. Let's say that this is 5 and drop is 7. Then if I get any time here, drop would kill me. If this is true after up operation. After possibly making my operation, I don't want to be in this dead zone. So basically, I would say that this small area, starting a day in this small stripe, would kill me. Because this is part where I cannot use up operation. Let's remember, red line, it means that everywhere above it, if I use up, I would hit a ceiling. This white stripe, this is that area. I don't want to start a day there. If I start below, I will go up somewhere and then drop by less, so I will survive. Right, let's now remember what is small. X. X is drop. So we know that this is small. But also because of that, we know that this is small. Because it's smaller than drop. All right, now that we have this proper understanding of the Flappy Bird game, let's try to solve it. The up move can be very long. Like it can go here and then a lot of drops. If we drop here, that's bad. But after every move up, even if we are very high, we can in constant time compute how many times we need to drop to be, let's say, below this line. I will call it yellow line. And now if below yellow line we are still above red, then we are dead after the next day. And if we are here, then I will go up again. So let's say that I'm at any moment somewhere here. In constant time, I compute the number of days with some division. To do this, let's say that I jump over the dead zone. Then I know that from here I will jump very high. I don't know where exactly, maybe even higher, and then do this process again. Maybe they're now entering the dead zone and I'm dead. I don't actually go through this part linearly. This is O of 1 with division to go from there to there. So I only consider those interesting points. And well, because of drop is small, drop is exactly height of the yellow line. This is 7. This is drop exactly. So whenever I'm here below, that's only million possible values. So whenever I, for the second time, visit the same value, I call that a cycle. And I say that, well, if I'm cycled, then apparently I survived. Nice question. It's not in the FAQ. What? College CGA. What is CGA? I didn't understand the question by Harsha Molia. Yep, this all seems good. Accumulate grade. In FAQ, doesn't it say that I'm a dropout? I studied in University of Warsaw. I don't anymore. So I had some like best grades, and like in some subjects I had the best possible grades. Those subjects where I really tried. Right? Problem is solved, right? I would say it's a normal ICPC problem. Not really common for Codeforces. Why drop out? Why not? I think it's answered in FAQ, isn't it? Cool problem. I saw something like that in ICPC many times. I'm the one responsible in my team for solving such problems. We responsible for physics or this just, casework. But do we want to implement? I can implement pseudocode / brute force. But I don't think I will get to code that I can submit. Right. We read the input, sure. Maybe some ifs to check if we die in first day. What else drawing said? If up smaller than drop, check if we die still alive. And that's it, then otherwise yes. And if we are still not dead. If yes, then yes. And then the hard part. We have some initial value, k. The value is greater than drop? No. Yes? No. I want to get below the value where something interesting is happening. Because of this, now I know that up is greater equal drop. Wait. What is 5? I think I made a mistake. 5 isn't up. 5 is height of everything minus up. Five is height minus up. No. If height is r minus l. Minus up, this is this height. If this is greater than drop, then yes, it's possible. This would be a case, I think, where this red line is above the drop line. So if we are below drop, then anyway, for sure, I can use up operation. Example. Let's say height is 10. Drop is 3. No, I don't want. I still consider only cases where up is greater than drop. Okay, so drop is 3, up is 6. Now, there is here 3, there is here 4. And what happens? Whenever I start a day above 4, I can drop. Actually, whenever I start a day above 3, I can drop, and this is fine. Whenever I start a day below 3, I can always use up, because I will not hit a ceiling. So everything is fine. For this drawing, the answer is yes. I will survive forever. Hence this thing. And now otherwise, there is this non-empty dead zone. This thing. And now, as long as I'm above drop, then minus equal drop, then eventually we are somewhere here, and we need to check if we are in the dead zone. Zero is also fine, right? Right, now, if I can now use up, then it's fine. But if value plus up would exceed height, then no. Equivalent version, the current value where I am, is greater than height minus up, which is that lower bound of lower line for the dead zone. I'm in the dead zone because I'm smaller than drop and bigger than that. Right? Otherwise, value plus equal up and minus drop. Because immediately after my move of up, there is a drop. But I know that up is greater than drop, so it increases. Right? Additionally, we have if visited already contains my value, yes. Set ints are enough because those are only for values up to million. This will guarantee that I will have at most million iterations of this while loop, and still this is very slow, it's 10 to 18th. But this can be done with division. It's something like, I believe it's exactly value modulo equal drop. But as we do this, obviously we need to update the days. Like current day plus equal value divided by drop. Yep, and day greater than t, yes. Because you survived t days. And also here day plus plus, and maybe also with this. Yes. Because this means one move, and here we have a lot of moves skipped. I think that's it. Many people can come up with pseudocode. Are you saying that I'm bad at coding? Any questions? Why Tourist doesn't upload video on YouTube? He has great potential. I mean, are you sure that the best person in the world is in some science niche, should teach others instead of trying to do research? I can teach people, and I will let Tourist do the research or whatever he's doing with his life. This is if we talk about what's best for humanity in total. But also, this is not the only important thing. It's not that if you're great, then you need to reproduce and you need to teach others or something like that. No, it's up to you. Tutorial. This was problem E. If y is smaller than x, quite easy to calculate the answer. Yeah, check first and check after it decreases t times. Otherwise, let's note k mod x as many times as we can, then raise the level. Further, we note blah, blah, we are in a cycle. Okay, the solution is the same. We have this modulo thing. T is the remaining number of days. Minimize that with T. Yeah, it's the same. I would prefer my code because drop and up seem better. Like with X, Y, K, you can make a mistake. All right. What time is it? It's time, I think, to end the stream or solve the last problem. Ramsan Kar, you posted the same link 3 times. Stop. The other thing is that I believe next time messages on the screen should be displayed longer. I'm not sure because I cannot reply to them in like 10 seconds when I'm doing something else. So maybe if chat isn't moving very fast, then they should just stay there. It will be better. Not sure about it. In Discord, you can let me know later. When first Google Code Jam, I tried 5 years ago for sure, but I was in the finals first time maybe 3 years ago. I don't know. Problem set. Let's solve problem of mine. What about that? I don't remember my old problems, so don't worry. It will be new for me. Codeforces 318. Barren blocks. What's the difficulty? Can I check here? 1600. Okay, that's easy enough for the end of the stream. Homework stream where this yeah, I thought about homework problems and I don't think they are good. So the thing with homework problems is that then I would choose slightly harder problems, but still, let's say half of the viewers would not know the problems in advance. If I adjust the speed of explanation to those people who know the problems and thought about them, then the experience will be worse to those who do not know the problems. These homework problems make sense if there is a small number of students and we have regular classes and most students attend every class. Then homework problems make sense. Otherwise, I'm not that sure they do. Because it is convenient to not need to know problems in advance and be able to join the stream anytime. But yeah, for the sake of for best learning curve and it would be best for you if you want to spend that time between lessons, between streams, it would be best for you if I give you homework problems. We can have a 10 to 15 people group for homework streams. But it's not that I want to have additional stream. I want to have a stream kind of for everybody. It isn't a solution for me to make another stream. I now have 3 streams a week. I don't want to have 4 like regularly. I invite you to discuss that more in Discord server. By the way, this is the link. You can join. Favorite type of problems to solve? Used to be dynamic programming. Maybe now that's just too standard. And at CoderDP problems are too hard. What do I do for a living? Exclamation mark job. Here you go. And read frequently asked questions. Right, barren blocks. Link. Here we go. There are n towers in a row. Ith tower has height h of I. Like this. Don't you think that this is a very nice drawing? I'm always proud of drawings in my problems. I even heard this from Codeforces coordinator. I don't know which one. That my drawings are very nice. Whenever possible, I make a drawing to make things clear. Let's just open everything. Maybe there are more. Okay, there are not more. But still. Block is called internal if it has all 4 neighbors. Otherwise, block is boundary. He destroys all boundary blocks. How many operations will it take to destroy all towers? Well, this one doesn't have 4 neighbors. How do we count bottom blocks? Or to the floor, all right. So here, only those 4 will survive the first iteration. Fine. The heights are up to billion, but for sure in n steps, n over 2 steps, everything will be destroyed, because in first step, in particular, the first full column is removed and the last column is removed. At least that. So n over 2 is a limit. Are you solving your problem? Yes, it is my problem. But thanks to my very poor memory, it doesn't matter that it's my problem, because I don't know a solution. All right. If there is some column with very high neighbors, then at least its size will decrease by 1 every time. If it has some higher neighbor, then, and everything else is very high, then this gets removed because it's neighbors with nothing. This gets removed. I think after one iteration, everything will look very regular. Okay, here's the claim. Height of I minus height of I plus 1 doesn't exceed 1 after the first iteration. Because if there were 2 columns with very different heights, then they are kind of even. No, this lemma is not true. What if there is this, that. Here, in the first iteration, we removed this, that, all of that. I mean, this got down to height 1, and this can be height 10. Okay, lemma is not true. Burned poker is a nice problem in this contest. Yes, it was a very nice problem. No. Yes. Can double and triple. Okay, it's a simple but cute problem. I think very fine for A. So you can later try to solve it later yourself. Oh, I couldn't copy. Done. But we're trying to solve this one. I think the problem has something to do with like limitations when we will finish. When something has height equal to 7, then we know that the answer is at most 7. If we know if something has height 2, there, no matter how big neighbors are, this will die in first turn. Then in the second turn, and so on. Oh, no. That would assume that this small column is first. But maybe everything here is very, very high. Actually, I will make a different drawing. That big. And those are columns. In first column, you die. In second turn, those. Same here on the left, obviously. Then this is the third turn. This is the fourth. And so on. It always lag behind like that. Okay. If this column was completely destroyed in second turn, then this one is in third, fourth, and so on. So I can write down those values everywhere, and I know that at most in this turn, this column will be destroyed, no matter how high it is. For brute force solution would be this, I mean quadratic solution. For every column, go in both directions like that and mark those times when a column is destroyed. And then among all the marks for some column, take the smallest value. This means that just looking at this column, even if everything else is infinitely high, for sure this column is removed in turn 4. Maybe earlier, because maybe something is very small here, or one of those columns is very small. But this means minimize the answer for this column with 4, this one with 5, and so on. And then at the end, my program will actually, for every column, compute when it will be destroyed. And this quadratic solution can easily be improved to linear thing, just because of how regular thing we have. We will have one iteration to the right and one to the left. Hi, Markodef. Like here. Yeah, let's simulate stuff for this test. This column gets removed in first turn. Then this one is second, not third, fourth, fifth, in second. I want a bigger drawing. At most, in this turn, you die. But actually, if we look at this column, it will die completely in first turn, just because it neighbors with nothing. So this one will die at most in second, third, fourth, fifth, sixth, and so on. When we look at this column, it will die in first turn. So we'll trigger this death in second, third, fourth, and so on. And also every column has some height, and we know that it will die in this, right? I think so. I don't know if that's needed. I can write down height of every column. because I know in that many turns it must die. Then for every column, I compute the minimum of those. I should also see what is triggered by the third column, fourth, fifth. Maybe that's not necessary in this case. I take minimum of everything, of every column, 1, 1, 2, 3, 2, 1, and I claim that this is the time when everything dies. First column will die in first turn, second in first turn, second turn, and so on. And I think it matches what happens there. First two columns and the last one died in the first turn. Yeah. Now how to do it fast? We need to once go from left to right and once from right to left. When going to the left and from the left and propagating this minimum, we just keep the minimum. If we know that we processed few values already, and one of them, let's say here, triggered that this would be 3, then 4, and so on, and this is the smallest of possibilities. Like if something else triggered 1, 2, 3, then if something else triggered here 1, 2, 4, 5, 6, and so on, then I can skip this. So I keep a single value when going from left to right, the minimum for this column to propagate to the right, and then when going to the right by 1, I increase it by 1. Let's see if 5 years ago I had the same solution. In one operation, the highest block in each tower disappears. What? So do all blocks above heights of neighbor towers. Okay, there is some proof here. For each I, we are looking for minimum of this plus I. I see. This is not the same explanation, but we do the same. We go from one side to the other. So we go from left, also we do right. We increase by 1, keep minimum. What, maximum? Are you sure it's maximum? I see minimum in the code. Maybe editorial describes something else. Seems like it should be rated more than 1600. Well, the difficulty rating wasn't invented back then. Difficulty rating is something newer. It doesn't matter that much. I need to later read this editorial and understand it. Maybe this should say min. Yeah, I'm quite sure this should say min. Create a new series solving my problems? Maybe it's a good idea. Some of them are very hard. Are there more features for high-rated users? A little bit. They are a bit related to trust, so you wouldn't mess up gym contest, for example. Yeah, this is minimum. I'm going to correct it now. Why edit wasn't triggered? Annoying thing is that now the block will appear here in the recent actions. I would appreciate an ability to do it without doing that. Maybe something was changed. Wait, do we still have? No, this was changed to minimum. And I don't see a block here. That's nice. Maybe they made a change. Now for small changes in old blocks, it is not here again. Yes, normally it is sent to recent actions. I'm going to read this later. Might be interesting. How nobody figured out from comments? Editorials are mostly to understand what's going on. Single formal isn't that important. And yeah, the stream is over. Anybody streaming? Nope. Looking for somebody to rate if they do competitive programming. Check out the schedule and join the Discord server. I hear echo. Oh, it's here. I don't see anybody doing competitive programming. Any recommendations, chat? Rate Chow again? I mean, he does something much easier than we do. Hand simulator. Stream on CodeChef cheating once. Yeah, I'm going to, but not a high priority. You mean here somewhere there was hand simulator or what? Did you ever get depressed? Not. No, I wasn't. I was... I don't know, maybe I'm lucky. Codeforces on Twitch isn't that common. That's true. Right. You can go watch Chow. I mean, it's not that he's doing much easier stuff, but still it's entertaining. Here's the rate. Thank you all for watching and see you next time. Bye bye. On Tuesday, by the way, I am Chow codes. On Tuesday, I will solve AdCoder hard problems. Maybe tomorrow I will make something on CodeChef, but not likely. Okay, rated. Yep. Bye, guys.